Chapter 14, Section 2 in the 8th grade note-taking guide is entitled Simplifying Polynomials. So we talked about polynomials yesterday. When we're talking about polynomials here today, we could be talking about a monomial, a binomial, a trinomial, or just a generic polynomial here. What we're doing here is we're going to be looking for terms. Remember, terms are separated by addition and subtraction signs. We're going to be looking for terms here that have the same variable being raised to the same power. And when we see those terms that have the same variable raised to the same power, we're going to combine them using whatever sign is directly in front of them. And that's how we simplify a polynomial. So really we're saying add and subtract the things that have the same variable. Should be easy enough. So what they're going to start off here with in number 1, part A, B, and C is they're just going to ask me to identify what is a like term here. Which terms are alike in the polynomial. So in 1A, you've got 5x cubed plus y squared plus 2 minus 6y squared plus 4x cubed. Okay, so as far as spotting like terms here, as you can see, what they've done is they've gone ahead and identified 5x cubed as matching up with 4x cubed. Why? Well, they both have x cubed in them, or x to the third. So that means 5x cubed and 4x cubed are a set of like terms. They've also gone ahead and identified y squared and this negative, notice it's got a minus in front of it, so that's why I'm saying negative, negative 6y squared as being like terms. Reasoning, because they both have y squared in them. So the only thing that doesn't have a match is the 2. And of course 2 would match up with any other plain old integer that we have there, but since there's no other integer on the list, he doesn't have a partner. There is nothing that's like when compared to the number 2. And that's all they want us to do in this one. Down here in a minute in number 2, they'll have us actually start combining the like terms, but right now all they're having us do is identify the like terms. Now as we take a look at B, B looks more complicated because there's certainly a lot more variables going on in there. We've got 3a cubed b squared plus 3a squared b cubed plus 2a cubed b squared minus a cubed b squared. Well, as you can see, here we have 3 different expressions with a cubed b squared. 3a cubed b squared matches up with 2a cubed b squared matches up with this negative a cubed b squared. Reasoning, because they all have a cubed b squared in them. And that's why those are like terms. Now, what this really is all about is making sure that you identify that they have to have all the variable parts the same. For instance, if this one said a squared b squared in it, all right, even though it has b squared in it, all right, it would not match these other 3 guys because these other 3 guys say a cubed, but this one says a squared. It's got to match all the variable parts here in order to be considered a like term. As we go ahead and take a look at part C, we've got 7p cubed q squared plus 7p squared q cubed plus 7pq squared. Well, here we don't have any matches at all, so there are no like terms. This one has p cubed, this one has p squared, and this one has regular old p. Since none of those match, we can guarantee just based on that fact that there are no like terms. We would see again that these outside terms both have q squared in them, which is great, but the problem is they don't match the p terms here, so there are no like terms. Alright, so now they're going to have us go ahead and actually start, instead of just identifying the like terms, now you're actually going to combine the like terms. So in number 2, part A, they've got 4x squared plus 2x squared plus 7 minus 6x plus 9. Now what they did here in the first line is they wrote these in standard form. And by writing them in standard form, what they mean is to write them in descending order. And that's not actually a required step to combine like terms, but it definitely will make things easier. Descending order is pretty custom across all different textbooks. Descending order simply means that you're going to write them with the greatest variable term first, falling on down to the lowest variable term or no variable term. Generally, we would use the degree of each term to write this, meaning what would be important there is if we had two variables like p to the fourth and q, we would write them based on the largest exponent. The other way to do that is just simply pick one of the variables. The way you can do descending order. Here, it's not really important because we only have one variable. So what they did is they wrote the x squared things first, which actually did not require me to change anything. Which one goes first is completely irrelevant because they're both x squared. Then they wrote the x thing next, and then they wrote the two things without x, the integers, at the end. And as you can see, when we do that, it's really grouping together all of our like terms, because as you can see what happened here, our x squared things got grouped together, which we're going to then combine here, and our integers got grouped together here, which I'm also going to combine here. Alright, so let's go ahead and combine those like terms. We've got 4x squared plus 2x squared. Well, think of it this way. If I were to give you 4x squared, and then I were to give you 2 more x squareds, how many x squareds would you have? Well, you'd end up with 6x squared, which is why it says 6x squared. Then it says minus 6x, and that's indeed just gets transferred down into part of my answer. And then here it says plus 7 plus 9. Well, 7 and 9, as we all know, goes together to make 16. So we write plus 16 at the end. So 4x squared plus 2x squared plus 7 minus 6x plus 9 combines to make 6x squared minus 6x plus 16. Now, in question number 3, we've got 3 times x cubed plus 5x squared. Now, this is a different type of question because what this one is about simplifying with the distributive properties you see written out here at the side. Notice what they've got is they've got a number in front of a set of parentheses. Well, as you know, when we have a number in front of a set of parentheses, we have to take that number that's in front of the parentheses and multiply it through to the things inside the parentheses, which is what I'm prepared to do. So I'm prepared to take the 3 through to the x cubed and the 3 through to the 5x squared, multiply, which will then also simplify, which is great because that's what the directions say. So 3 through the x cubed, well, you're just going to run those things together. There's nothing to do there other than to put them together. So 3 through to the x cubed is going to give me 3x cubed, which is what you can see this first part of the answer is. And then 3 through to the 5x squared, well, 3 times 5 gives me 15, and then I got the x squared at the end, so that's 15x squared. So that's 3x cubed plus 15x squared. All right, let's go and take a look at number 4. The surface area of a right cylinder can be found by using the expression 2 pi parentheses r squared plus rh, or 2 pi times the quantity r squared plus rh, where r is the radius and h is the height. Use the distributive property to write an equivalent expression. So this is more practice on what we did here in number 3. It's again me using the distributive property and taking what's in front of the parentheses and multiplying it through to the things that are inside the parentheses. I have to take the 2 pi and carry it through to the r squared, and take the 2 pi and carry it through to the rh. Well, when I take 2 pi through to r squared, I just run those things together. I don't have to actually do anything, make it look any different. I just put them together. So that's 2 pi r squared. I do the same thing with the 2 pi going through to the RH. I take the 2 pi through to the RH and I just put those together. And that gives me 2 pi RH. So final solution there, 2 pi r squared plus 2 pi RH, which is a formula you know. You've seen that because that is indeed the formula you've learned for surface area of a cylinder. All right, let's go ahead and take a look at the concluding examples here in the Check It Out section. Number 1, identify the like terms in the polynomial. So, again, like terms, you're looking for same variables to the same power, same exponent here. So, if we take a look at 4y to the 4th, we're looking for anything else with y to the 4th. Well, if I look at the end here, I see there's 2y to the 4th. So that is a set of like terms. 4y to the 4th and 2y to the 4th are a set of like terms. That's the first answer they identify here for me. All right, the next thing I see is y squared. Well, y squared is going to match up with anything else that says just y squared in it. And as you can see here at the end, there's a minus 8y squared. So those guys are also a set of like terms. 2 would match up with anything else that's just a plain old integer, but there is nothing else, so he does not have a partner. 2 does not have a like term in this question. All right, let's go and take a look at number 2. We've got 2x cubed plus 5x cubed plus 6 minus 4x plus 9, and they're simply asking me to simplify, or in other words, combine the like terms here. So as you can see right away here, they threw a couple right at us, and they already grouped them together. Remember, in the earlier question, we actually had to take the time to do that, but they already did that for us here, at least with the x cubes. So we're going to put the 2x cubed and the 5x cubed together. That's going to give me 7x cubed. Now I see I also have a couple of regular integers here. I have the 6 and the 9, which is going to go together to write 15. But as you can see, they put that at the end. And the reason they put that at the end is because they wrote this in standard form or descending order with the greatest exponent first and the least exponent last, which is why the x term here is in the middle, because that would have an exponent of 1. This has no exponent at all. So they wrote 7x cubed minus 4x. Notice they wrote minus 4x because that's exactly what it says. It does say minus 4x in the question, plus 15. Number 3 is all about the distributive property again, like question 3 and 4. It says negative 2 times 6m cubed p plus 8m squared p, and that's all in parentheses, plus m squared p. All right, so we're going to take the negative 2 through to the 6m cubed p and the negative 2 through to the 8m squared p. So I've got negative 2 going through to the 6m cubed p. Well, that's negative 2 times 6, which is going to go together to make negative 12, and that's m cubed p. And then I've got the negative 2 through to the 8m squared p. Well, negative 2 times 8 is going to give me negative 16. And that's going to give me m squared p. Now, as you can notice here, at the end, they've got a plus m squared p. Well, that's going to match up with this term because it also has m squared p in it. So those are going to go together, and that's why the solution line here only says minus 15m squared p, because this is 1m squared p, and if we take away 16m squared p's, that's how I end up with negative 15 m squared p's. So negative 12 m cubed p minus 15 m squared p's. Remember, if there's no number in front of it, as you heard me explain verbally, but I'll point it out now, if there's no number in front of it, it's like there's a 1 there. Now, this does give me pause for just a moment here, because let's say it was a distributive property question where I said 2m times 3m minus 6n. Well, the 2m and the 6n, I'm not all that worried about. Most of you know we're just going to run that together. The 6 and the 2 is going to go together to make 12, and then you'd have m and an n. But do you remember what to do with 2m and 3m? I hope you do. 2 times 3 there would give me 6, which I'm guessing you all come up with. But then you've got m and m. Well, you're not going to write m times m. M times m is the same as m squared. And that's one of those power rules that we've learned, is when we're multiplying together powers with the same base, we add their exponents. So since this has an exponent of 1 and this has an exponent of 1, they go together to make an exponent of 2. So what if this said 2m cubed? What would that make then? Well, 2 times 3 would still give me 6, but m cubed and m to the first would make m to the fourth. All right, number 4. The surface area of a right cone can be found by using the expression pi r times the quantity r plus L, where r is the radius and L is the slant height. Use the distributive property, write an equivalent expression. So again, this is all about you taking what's in front of the parentheses and multiplying it through to the things that are inside the parentheses. So pi times the r has to go through to the r. Pi times r has to go through to the L. Well, here we go. Here's exactly what we were just talking about. Pi times r being carried through to r. So we have pi r. Well, pi r is not going to be pi r. We're going to write pi r squared, because remember, we're adding the exponents, and since there's no visible exponent there, it's like they're both 1s. And then pi times r being carried through to L makes pi rl, and we keep addition in the middle, so this simplifies to pi r squared plus pi rl.